Okay, this video is about Boyle's law. Here's the equation for Boyle's law. And Boyle's law assumes that we have a constant temperature in moles, and that we're only dealing really with our pressures and our volumes. And essentially, Boyle's law states that as you increase your pressure, your volume decreases, and vice versa. Okay, so here's a random problem. This is your homework, but I changed some numbers so that you have another example problem. So we use the guess method this year at Gilbert High. Okay, and so I strongly recommend using this method because it helps give you a roadmap of where to go in the problem. So first thing you should always do is you should be reading your problem, identifying what you're dealing with. So it says a sample of gas occupies a volume of 3 liters at 65 kilopascals. What volume will it occupy at 2.4 atmospheres? So G stands for givens, and I'm going to go ahead and start writing down anything that I underlined. So we know that liters is volume, so we know that the first volume they gave us was 3.0 liters. And this sample of gas is at a pressure of 65 kilopascals. So I'm going to say that that's pressure 1 because those two numbers, they go together. I know that kilopascals is pressure because I just learned that. So kilopascals, atmospheres, and millimeters mercury, you know should be pressure. Okay, it says what volume, so they're looking for volume. So we're going to say, okay, V2 is my unknown. Will it occupy at 2.40 atmospheres? Again, we know that pressure is also in atmospheres, so P2 is going to be 2.40 atmospheres. So I see here I have 2 P's and 2 V's. And Boyle's law is the only equation I can use because Boyle's law has 2 P's and 2 V's. Now, one quick note, when you're dealing with pressures, if you want to do math with your pressures, they have to be the same unit because math says so. So what I need to do is I need to convert one of these guys to the other unit. I think I'm going to convert my atmospheres right here to kilopascals just because I want to. Okay, and so the way I'm going to do that, I'm going to do it right up here. I'm going to say 2.4 atmospheres. I know that for every 1 atmosphere, there are 101.3 kilopascals. And I'm going to plug that into my calculator. I'm going to say 2.4 times 101.3 equals 243.12 kilopascals. So now, I have kilopascals and kilopascals. I have liters here, which means I'm probably going to be looking for liters there. I have an equation that I chose, so now I can solve. So I first substitute into the equation right here. So if it's P1 times V1, I'm going to go find my P1. That's 65.0 kilopascals times my V1, which was 3 liters, is equal to my P2, which we decided was 243.12 kPa, times my volume, which I didn't know. So in my opinion, Boyle's law is like one of the easiest gas laws, and the reason why is because you don't have to do an extra step with cross multiplying. You're already at that place where you have the two numbers equal to each other, so all you have to do is divide by whoever your unknown is touching, so that your unknown is left sad and lonely. Boom. Those guys cancel out. And now I'm left with my volume, and I just have to plug this fraction right here into the calculator. So I'm going to say 65 times 3 divided by 243.12. And this becomes 0.80 liters. And if I'm stressed about if I did my math right, I can go back and think about the math. We know that Boyle's law says that if you increase your pressure, your volume should decrease. So right here, we started with 65 kilopascals, and we went to 243, which meant that our pressure went up. So if we did our math right, then that means that our liters, or our volume, should have gone down. We started with 3, and we ended up with 0.8. So we just verified for ourselves that our math is on the right track. Okay? Not all problems are you going to have to do this stuff where you have to like convert to the pressure. I just wanted to give you kind of a hard one for you to practice. But as you're doing these initial problems, chances are you're going to be given 2 kPAs already. But I wanted to give you a challenge problem right here in my video.